Hello everyone and welcome back to the channel. So based on popular request, today we are going to be looking at the MCQ predictions for paper 1-2 for AS Physics 9702. So this comes off a lot of comments for people who were requesting this. So we know that for MCQs you have a total time of 1 hour 15 minutes and you have to do 40 questions in that time. So this is going to go over like the probable questions as well as the expected number of questions from each chapter. Let's get right into it. So chapter 1, which is physical quantities and units, we are expecting 3 to 4 questions broadly from these subcategories. So basically what it means to be a physical quantity. For example, we know that physical quantities have a unit and a magnitude. So that's the basic idea that would be used in any question. Base units, so this could be a question in which you have to use homogeneity if it's more complicated, and that could even be as complex as having an unknown power and finding the value of the unknown power, or maybe it's just using homogeneity to figure out the units of a constant. Estimates, so some people usually get very tangled up with the estimates question. If you feel like it's difficult, or if you feel like it's going to take you some time, just skip it for now, but do remember to come back to it later. Percentage uncertainties definitely going to be asked. It wasn't asked in paper 2 as it usually is. So some idea of percentage uncertainties will be asked. Systematic and random errors could also possibly be asked. And similarly, vector addition in terms of this, that for example, if you have like one vector that goes like this, which is V, the other one which is like this, which is U, and the examiner asks for what V minus U looks like, right? So questions like this can come in. This is what I mean by vector addition. Next chapter is chyomatics, not assessed at all in paper 2, which is a really strange thing to have. So we expect it to be assessed more in paper 1. So displacement, velocity, acceleration time graphs. So specifically that type of question where you have either a velocity time graph given, you have to figure out the displacement time graph. Or if you have an acceleration time graph given, you have to figure out the velocity time graph. Or the most difficult one where you have an acceleration time graph given and you have to figure out the displacement time graph. So that's one type of question. Area from velocity time graphs, it could be like a simple one as well. Or you might also remember seeing questions like this where you have a velocity time graph that looks like this. So you have a positive area as well, you have a negative area as well, and the subtraction of the two gives you the net distance traveled. So questions like that. Projectile motion, similarly some questions, and that would utilize some usage of equations of motion. Or you could have a theory question as well. For example, where how much is the speed at a certain point, if you're just like qualitatively talking about it. If it's not going to be a if this is not going to be a calculation question, then you'll have equation of motion numerical questions, and there might be a question with kinematics which is symbolic, so that's based on ratio or proportions. So that's one type of question, and from this you'll have like 3 or 4 questions. From dynamics or forces, you'll definitely have some question related to F equal to ma. If the examiner is feeling really nice, this could be a calculation question. Otherwise, this could be a question where you are either expected to work with a force time graph or a acceleration time graph to figure out what a velocity time graph looks like. Or similarly, you might also have momentum time graphs. So remember that the gradient of a momentum time graph is resultant force. Newton's third law also, it's a really high probability of being assessed tomorrow. Conservation of momentum reasoning in terms of elastic inelastic collisions. Elastic inelastic was asked, but not in terms of relative speed of approach and separation. So that has a high chance to be assessed. Terminal velocity, somewhat low chance, but still can be assessed. 2D momentum, if this was a reasoning question, then this is going to be a calculation question, and vice versa. And connected body problems, where you have, for example, pulleys, or you have had questions in the past like involving a lift, or for example, one of the more difficult questions I remember was the child pulling on a sledge and that rope was going around a pole. So all of those are examples of connected body problems. So if you don't know this, then make sure you do before your exam tomorrow. Chapter 4, forces, density and pressure. Again, expecting 3 or 4 questions. One question is almost definitely going to be couples, calculations, or just figuring out or saying which one is a couple or which one is not a couple. Conditions of equilibrium in terms of like resultant force should be 0, resultant moment should be 0. Principle of moments, you could have like a small working on this, and yeah, so that's what we expect. And then density of mixtures is something that you have had questions over. Some people struggle with this, although this is really just algebra. Upthrust will also definitely be asked because it was not asked in paper 2 at all. So there could be like a formula sort of application, or it could be just like a theoretical question where you have to like say what is the upthrust on some object versus another object. Or in the past, if you look through the past papers, you'll also see questions where you have had in the context of forces a graph of upthrust. So just be ready for that type of question as well. Work energy power was assessed, so we're expecting like lesser 2 or a maximum of 3 questions. Work done calculation, which is a very simple question. At most, the problem could be something like this, that it's covering some distance in this direction, but the force is applied like this at an angle. So then you'll just resolve. Conservation of energy and how you find out work done against friction. This type of question can be asked. Efficiency numericals are like really common in terms of like, and this could also be mixed in with some electricity, P equals to VI sort of question. P equals to FV definitely going to be asked. And definition of power in terms of rate of work done or rate of energy transfer. Remember that this is the definition, this is not the definition of power. Chapter 6, so deformation, you'll have a stress strain graph. Now this could be either in terms of locating different points such as the limit of proportionality or the elastic limit, or figuring out elastic versus plastic deformation. Ratio questions, we have done those a lot. So in terms of the questions which are like ratio of stress in X over stress in Y, or ratios of extensions or something along those lines. So you have like a lot of examples of that in the past. Area under force extension graphs and how it can be used to estimate work done, how you can figure out the net work done in terms of the loading and unloading curves. Spring constant calculations, this will be like a really easy question just to help you score marks. And then the spring configurations, which is springs in series and parallel. So how you find the total extension or how you find the spring constant, that's going to be part of this. Chapters 7 and 8 I've grouped together, so waves and superposition. Components of EM spec, so for example, if the examiner asks you what is like the wavelength or the order of magnitude of the wavelength of gamma, or maybe the frequency of radio, so you need to be able to like select the correct option in that case. Phase difference calculation, so if you are given a displacement time graph or a displacement distance graph and you are given 2 waves, or also for that matter 2 points on the same wave, so how you find out the phase difference between those two, so that's important. Doppler effect, how you calculate the usage of the formula and its theory in terms of how you have a greater frequency and what's the difference between just a greater constant frequency and an increasing frequency based off the movement of the source. So things like that. Malice's law. So Malice's law is linked to polarization. If the examiner is feeling nice, again, you can just have a question in which he asks that which wave cannot be polarized. So the answer to that one is that a longitudinal wave cannot be polarized. Stationary waves calculation, this is also like it's a really good chance of this coming in terms of harmonics, or for example you have those experiments where you have one stationary wave forming here, another forming here, and you have like a loudspeaker at this end, so you're asked to find the wavelength. So remember that the difference in levels of the water is equal to half the wavelength, right? So questions like that, or figuring out what's going to be the next frequency at which a stationary wave is set up, things like that, or like properties related to stationary waves in terms of phase difference and whatnot. So that could be asked. Maximizing diffraction, so sometimes you have a question based on like how the wave fronts are and how you can maximize diffraction in terms of the gap width. And sometimes you also have these based on some application of E equals to F lambda, and then you have to comment. So questions like that. Either the diffraction grating or Young's double slit is going to be asked, in my opinion. It's also probable that both can be asked. So again, I forgot to give this disclaimer at the start, but this is just my gut feeling and the pattern that I've seen over the last couple of years, and what I can gather from seeing your paper 2 question paper that I have with me right now. CROs, so basically how you read off the time base to find the time period, how you use the Y gain to find the amplitude. Intensity amplitude relationship was asked in P2, so there's a low probability of being asked, but I've included it still because I don't remember actually seeing a paper in MCQ in recent years where there was not a single question on this. There have always been questions on this. Displacement distance graph in terms of maybe sound particles and how they would move. And similarly, where you have graphs and the examiner asks that which particle would move to the left, which one would move to the right, which is a compression, which is a rarefaction. So that type of question is this. And you'll also have like a good deal of questions from this as well. The most in your paper will be from waves in superposition. So I'm going for approximately 8, but may as well be as much as 9 questions. Chapters 9 and 10 related to electricity. So current electricity and DC circuits, I've grouped expecting like 7 questions from this. And these are like the possible candidates. I equals to A and VQ. So usage or the reasoning of this. Quantization of charge. So remember that all charge is an integer multiple of the charge of an electron. VI graphs for filament lamp and diodes. So which way the graph curves, how is the shape, how is it different for a filament lamp versus a diode. So that sort of thing. Resistivity calculations, or you might also have this, that combined with this and this, you have a ratio question on electricity, right? So we can also expect something like this. There will be at least 1 or 2 ratio questions, right? There will be a minimum of 1 ratio question in your entire paper and a maximum of 2. So just be prepared for this fact. Voltage, current, resistance, power calculations, KCL, KVL, Kirchhoff's laws, their statement, and it's a conservation of which quantity. For example, KCL, the first law is conservation of charge. KVL, the second voltage law, comes from the conservation of energy. And series parallel resistance, so where you have like weird shapes given. So how do you figure out which one is in series with what and what is in parallel with another? For example, let's say there's a circuit that looks like this. And this is, by the way, inspired from a past paper question. And it says that current flows in from here and flows out from here. So the current splits up in this and this branches. All of these are in series, and that is in parallel with this one. So questions like that could be asked. Internal resistance, so terminal potential difference graph, or calculations are still less likely, but more likely are the ones where you have to comment on how the voltage or the current across a certain component is changing. Potential divider circuits with the LDRs and the thermistors, right? So voltage division basically, and the potentiometer also has a really high chance of being asked. And then the last chapter is particle physics, from which we are expecting 3 questions. My topics would be quark flavor, determining decay, isotopes, and fundamental particles. So 3 questions from any of these. So that approximately makes up like the 40 questions that are to be asked. So hopefully this gives you like some idea of what is going to be asked more. So make sure that what you see on this list, you do know this. And yeah, so yeah, you just need to like be really strong with all of this. So that's it from my side. This was a small attempt from me to help you guys out for AS. Unfortunately, I couldn't get a lot of time to do a live session or something, but still, yeah. So best of luck for tomorrow, and just do your best. Try not to fret a lot, and honestly, it might be a consolation to the ones who are doing well, and it might come off a bit bitter to people who weren't studying all year, which is that if you couldn't do anything all year, then you definitely cannot do this in one night. So just take a good night's sleep, because you'll need your mind fresh and working for tomorrow's paper. So like this video, share this with friends just to help them get this last ditch attempt in. Comment if you feel like something is going to be assessed and if I missed that out, and subscribe to the channel for more content like this. See you next time.